Let's go on to section 3.5. Introduction to rational functions. In math, rational means what? What's a rational number? Rational number. Someone asked Siri, what's a rational number? Or find it in the notes. Is pi a rational number? Is 3/2 a rational number? Yeah. Is 0 a rational number? Yes. Is 3 a rational number? Okay. No one's looking it up. It's a number that can be written as a fraction. So why is 3 rational? It can be written as 3/1. Is 0.97 a rational number? It can be written as 97/100. So rational, you should think fraction, right? But a rational function is now a polynomial divided by a polynomial. Okay, so we say R of x is equal to P of x over Q of x, where P and Q are polynomials. Consider the function f of x is equal to 1 over x minus 2. What's the domain? All real numbers except 2, right? X minus 2 cannot be 0 because we can't divide by 0. So that means x does not equal 2. Everything else, negative infinity to 2, union 2 to infinity, is the domain. So I can't plug in 2 because the calculator blows up. What if we plug in numbers near 2? What's your favorite number near 2? 1, 1.9, 1.99. Okay, so you see I'm plugging in numbers slightly less than 2. What do I get if I plug in 1.9? Can you plug it in your calculator? 1 over, what's 1.9 minus 2? Close. Negative 0.1. So what's 1 over a tenth? It's 1 over 0.1. Dividing by a fraction is the same as multiplying by the reciprocal. It's negative 10. What if I plug in 1.99? What do I get? 1.99 minus 2. 1 over negative 0.01. 1 over a 100th. How many times does a 100th go into 1? That's right, 100 times. What if I plug in 1.999? Okay. And the next one. So we're dividing by smaller and smaller number, which makes a larger and larger number. This is a very important thing to memorize. When you divide by smaller and smaller numbers, we get a larger and larger number. So as we say, as x approaches 2 from below, what does our y value approach? Good, negative infinity. Very good. So we say the y value of our function approaches negative infinity as x approaches 2 from below. Maybe I should write this out. F of x goes to negative infinity as x approaches 2 from the left or below. The value's below 2. But yes, you need to be familiar with this notation. On the other side, what if x approaches 2 from above? So 2.1, what should my answer be? Positive 10. 2.01? 100, 2.001. Good. And so we say in symbols, as x approaches 2 from above, from values that are larger, what's my y value approaching? Positive infinity. The y value approaches positive infinity as x approaches 2. X approaches 2 from the right or above. Here's the graph. As we approach this x value of 2 from below, my function goes down toward negative infinity. As my graph approaches 2 from above, my function goes toward positive infinity. and we say that we have a vertical asymptote here. This is the line x equal to 2. Whereas denominator 0, we have a vertical asymptote. Is that always true for all rational functions? When the denominator is 0, do we always have a vertical asymptote? That's an important question. It turns out if it's reduced, then yes. This one's reduced, so we have vertical asymptote where the denominator is 0. Yes. It's currently going around. Yeah. I passed it out late. Let's try this example to get familiar with the notation. What does this mean? Part A. As x goes to negative infinity. So I should look where on my graph? On the x-axis, I should look far left. And this is saying f of x represents my y value. What's my y value approaching as my graph goes to the left forever? 0. The y value is approaching a y value, a height of 0. Right? X represents the x value, so this means left. F of x represents my y value. My y value is going to 0. The x-axis has a height of 0. Right? Y value is the height. A little bit tricky, right? The next one. As x approaches, what does that mean? Good, 0 from the left. So now I'm looking here at x equals 0 from the left, and then I say my what? The height of my function is approaching what? Yes, so along here, my graph is going further and further, closer and closer to 0, but my y value is approaching positive infinity. If you write infinity, I'll assume you mean positive infinity. The next one. What does this mean? Part C. X is approaching 0 from the right. Approaching from the right. But along my function, what's my y value going to? Yes, positive infinity again. Okay, the next line means what? As x approaches infinity means we're going to the right. So if we follow our graph as far right as we can go, what's the y value approaching? Good. A height of 0. So that's getting used to knowing what's the x value, what's the y value, and how does it correspond to each other on the graph. We have a theorem on vertical asymptotes. So I said, do we always have a vertical asymptote when denominator is 0? The answer is no, but when it's reduced, we do. So if the numerator p of x and denominator q of x have no common factors, means it's reduced. And a is a 0 denominator, then x equals a is a vertical asymptote. Okay, the first one, f of x equals negative x squared plus 2x plus 3, all over x plus 1. Is it reduced? I don't know. Let's factor the numerator. What does the numerator factor into? Factors of -1 are -1 and +1. Factors of 3 are 3 and 1. Plus 3 plus 1. And on the bottom, we have x plus 1. So this reduces to make negative x plus 3. Okay, so my original, where's my function undefined when denominator is 0? So x equals -1, my graph cannot exist there in the form of my graph. What does my graph look like? After I reduce it, it looks like a line with y-intercept 3, slope -1. Y-intercept 3, down 1, right 1, down 1, right 1, down 1, right 1. Any questions about that? So before you reduce it, you need to find out where it's 0 because it's going to be undefined there. Undefined when x is equal to -1, which means we have a hole in the graph. The next one, we factor the top and bottom, 2 times x minus 1. On the bottom, x minus 1 times x plus 3. These cancel, and I get f of x is equal to 2 over x plus 3, but I need to make sure x cannot be 1 because it's undefined there, meaning there's a hole in the graph. Before you actually cancel factors, you need to decide where's it undefined. It's undefined at 1 and -3, but 1 is canceled, so there's a hole here in my graph. But when it's been reduced, x equals -3 is a vertical asymptote. Here's the line, x equals -3. Any questions about that? Definitely a lot of details here. Okay, next, behavior near the vertical asymptote theorem. So notice, as my graph approaches a vertical asymptote from the left, my graph goes to what? From the left. What happens to my graph? Goes to -infinity. From the right, as I approach -3, my graph goes to positive infinity. They're opposite. And it's because the exponent is odd of this factor. Okay, this one we talked about. 1 over x minus 0 squared. As I approached 0 from the left, it went to positive infinity, and from the right, it went the same direction, positive infinity. They both went the same direction because this was even. That exponent of the factor on the denominator. That's what this theorem is saying. That rule follows. Consider a rational function f in simplest form. X minus a to the power of n is a factor of the denominator. If the n value is odd at a, I have one of two scenarios. Here's my vertical asymptote. My graph either approaches the infinity from the left, positive infinity on the right, or the opposite. The opposite, it might approach positive infinity from the left and the opposite from the right. Now, I didn't draw the whole graph because I don't know what happens here, right? The graph could do anything. I'm just talking about near x equals a. Okay, however, if that exponent's even, I know I have a vertical asymptote there. And they both go in the same direction, either both up or both down. Any questions about that? Presumably, I could graph near my vertical asymptotes for this function, capital F. Is this rational function reduced? Are there any common factors on the numerator and denominator? No. So it is reduced. That means, what are my vertical asymptotes? X equals 3, x equals -4. Our vertical, can I put VA? Okay. Our vertical asymptotes, -1, 2, 3, -4, 1, 2, 3. Okay, I'm going to draw vertical asymptotes there. We draw them as dotted lines, so we know it's not part of our graph. And we know our graph cannot cross these lines. So at -4, what does our theorem tell us about the behavior? Near x equals -4. Same direction, either both up or both down. How can I figure out which? Plug in a value close to -4. Really close to -4. Let's say from the left. What value is really close to -4 on the left? What number might that be? -4.001. Are we okay with that? So if I plug that into my function, I'd have 1 over that number -3 and that number +4. All I really care about is my answer to this positive or negative. right? Am I going to positive infinity or negative infinity? What do you think? If I square it, it's always positive, right? What about this number? Negative. So what's 1 over a negative times a positive? It's negative. So that tells me that should be going down. And the other side should also go down. It's going to negative infinity. Any questions about this? Yes.
Can you plug in infinity?
Can you plug in infinity for x? What would plugging in infinity for x mean? Well, yes, it's not possible, but infinity's not a number. X, plugging in infinity for x would mean I'm going far right. It means I want to know what happens to far right. But that's not what we're asking right now. We're asking what happens near -4. Does that make sense? So I plugged in value near -4. Okay, this will work for you. Plugging in value near -4 will work for you for your problems. Unless, what if I had another vertical asymptote near -4? Then it wouldn't work for you. At some point, it would be really nice if you got used to this notation, -4, but slightly less than -4. -4, but slightly less than -4. And so it would still be about -7. We'd be approaching -7 from below. And we'd be approaching 0 from below. But it would still be a negative times a positive. So we would still get a negative. All right, we'd like to see what's happening near 3. So I know that 3, because this exponent is odd, I either have a scenario where one is down, the other one's up, or it's switched. This side, the left side is up, the right side is down. We know they're opposite because the exponent's odd. I need to figure out one of them. So how do I do that? Plug in your favorite number near 3. What would that be? Sure, that's from the right. 3.01 is what I heard. And that's fine. I only need to know one side. So 1 over that number -3 and that number +4 squared. Okay, I'm perfectly fine with you plugging in 3.01. I'm going to plug in what instead? I'm going to plug in 3 plus, meaning something slightly larger than 3. Something slightly larger than 3. What does that simplify to? What's something slightly larger than 3 minus 3? Slightly larger than 0. Yes, positive number. Very good. Times something slightly larger than 3 plus 4 is something slightly larger than 7. But it's positive. So my answer is positive infinity. So the other side, it should approach what? Negative infinity, because this exponent is odd. Okay, what we don't know how to do yet is how to connect these. Graphing this will be tomorrow's lecture. So far, I only care that you can graph near the vertical asymptote. Any questions about that? Yes. Okay. We now have horizontal asymptotes. Okay, I'm going to go over 3 scenarios. Now, I'm not going to draw these in red because we can cross horizontal asymptotes. We cannot cross vertical asymptotes. Maybe that's worth writing down. Okay, my graph will approach this y value and get closer and closer forever. Or my graph could approach this value on the other side, or my graph can cross the asymptote, come back to it, and approach it again. So in symbols, we would say that what's our y value approaching on the first graph? F of x is approaching. What's my y value approaching as x goes to infinity? Yes, my y value is approaching 3 from above as x goes to the right to infinity. For the next graph, I would say as x goes to the left, what's my y value approaching? 3 from below. In that exponent position, I'm writing a negative sign. And finally, this one, as x approaches infinity, as I go to the far, my y value is approaching -3 from above. And we get to the theorem on horizontal asymptotes. There's a lot to memorize in this section. Okay. The degree of the top is that leading exponent, n. The degree of the bottom is that leading exponent, m. So if the degree of the denominator is larger, what that means is, well, let's talk about an example. F of x equal to x over x cubed plus 5x plus 7. Okay, so when I'm talking about far right behavior, as x goes to infinity, the only thing that matters is the lead terms, right? And which one's getting larger faster, x cubed or x? X cubed. So x cubed gets larger so much faster that this thing must go to 0. That's what this theorem is saying. If the degree of the denominator is larger, my graph must approach y equals 0. That's a horizontal asymptote. If the degrees are the same, what that means is only the lead terms matter and they cancel each other out. So y is equal to 2/5 would be our horizontal asymptote. You just take the coefficients if the degree is the same and divide them. If the degree of the numerator is 1 larger, you're going to have a slant asymptote. If it's more than 1 larger, it's nonlinear, like parabolic or something else. Horizontal asymptote is what we approach eventually to far right and far left. Okay, so if I think of my graph and I say far to the right, which x values am I talking about? So far right. So the far right, which x values am I talking about? Like really large, right? 100, 1,000, 1,000,000. Really, x is going to infinity. So for these horizontal asymptotes, I'm really talking about large values of x. Okay, for instance, on this problem, I could plug in a large value of x and see that only the lead terms matter because 2 times 1,000,000 is way bigger than 3. You agree with that? Okay, what about here? 1,000,000 squared is way bigger than 1. Right? And then when I plug in a trillion, it's even that much bigger. So the point is, we only care about the lead term when we're talking about far right and far left behavior. So if I look at those, if the bottom is larger, if I look at 2x over x squared, if the bottom gets larger, what happens to my function? Okay, what's your favorite large number? 2 over 1,000 would be what? 0.002? Can anyone think of a larger number than 1,000? Okay, that would be 0.1234. So as my denominator goes to infinity, what's my number approaching? 0. Very good. Do you see how we're going to 0? Okay, so the rule we want to memorize, if the denominator, this exponent, we'll call that m. If m is larger than the exponent on the numerator, then we say the horizontal asymptote is y is equal to 0. So yes, go ahead. Yes, 1 is less than 2. That is correct. The degree of the denominator is larger than the degree of the numerator. That means the denominator will get larger much faster for large numbers. Therefore, my number must go to 0. So you can just memorize that the degree of the bottom is larger, then my horizontal asymptote at y equals 0. Okay, so that's what number 1 is saying. Okay, the next one. What if the degree of the top and bottom is the same? I look at the lead terms. 4x squared over 3x squared, they get large at the same rate. They cancel each other out, and y equals 3/4 will be the horizontal asymptote. Horizontal asymptote is y is equal to 3/4. Any questions about this? Yes.
Why do we flip the?
I don't know.
Oh,
We shouldn't. Yeah, thank you. Can you be dyslexic up and down? I don't know. Is it only left and right? Someone should know that. Any questions about this? It's still 3/4? 4/3? Thank you. Okay, so there's a horizontal asymptote here at y is equal to 4/3. Did I get it right? This one has a horizontal asymptote here at y is equal to 0. Can the graph cross a horizontal asymptote? Yes. But yeah, look at that blue line, it crosses. Doesn't have to, but it can. Can my graph cross vertical asymptotes? No, it's undefined there when the denominator is 0. Any questions about this so far? So the degree of top and bottom is the same. You just do the quotient of the leading coefficients. If the bottom has higher degree, then it's y equals 0. How do I know where my vertical asymptotes are? Review from yesterday. How do we know where the vertical asymptotes are? Where the denominator is 0, right? X squared plus 1 after it's reduced. This is reduced already. For which x values does that equal 0? Plus or minus square root of close. Yeah. So we subtract 1 from both sides. Square root both sides. X is equal to plus or minus I. Where does that occur on my x-axis of real numbers? Nowhere. So that's why I don't have any vertical asymptotes. No vertical asymptotes. Okay, what about g? Where is the denominator equal to 0? Divide by 3. Square root both sides. Plus or minus 0. What's negative 0? 0. Yeah, so we just have this one vertical asymptote, and I'll call this x is equal to 0. Okay, if the degree of the numerator is 1 larger than the degree of the denominator, it's called a slant asymptote. If it's more than that, it's called a nonlinear asymptote. So this one, you know what? Let's do long division just so we see what's happening. And so we practice long division. What goes underneath the division bar? Okay, I'm going to divide it by x minus 2. So I should multiply it by what? X squared. So what's x squared times x minus 2? X cubed minus 2x squared. And we subtract. If I subtract, oh, I wrote something wrong. It's x cubed, right? If I subtract x cubed minus x cubed is 0. What about the x squareds? 0 minus negative 2x squared is positive 2x squared. So maybe we should distribute the negative sign and then add. Bring down the next term. How many times does x go into 2x squared? Checks in. You look at the lead term, 2x squared, and you divide it by the lead term here. And we get 2x. Okay, then we multiply. What is 2x times x minus 2? 2x squared minus 4x. And we subtract, and we get 4x. Yeah, that's right. Plus 1. And how many times does x go into 4x? Plus 4. And 4 times x minus 2? 4x minus 8. Let's subtract, and we get a remainder of 7. So what's the answer to this? For x minus 2. Is it 9? Yes, it's 9. Thank you. Okay, so let's think about what happens as x goes to infinity. To the last term here. As x goes to infinity, what happens to this number? Okay, we went over this. 9 over a million, 9 over a billion, 9 over a trillion, 9 over a Googleplex. We're approaching 0. 9 over x minus 2 goes to 0. So the point is my asymptote looks like this. We call this a parabolic asymptote, but it's nonlinear. Nonlinear asymptote y is equal to x squared plus 2x plus 4. And we can ignore the other term. It's going to 0 to the far right and far left. Does this have any vertical asymptotes? Good. Once denominator is 0, x minus 2 is equal to 0 means x equals 2 is our vertical asymptote. Should we graph it for fun? You're not curious if we're right? What's your favorite graphing tool? Yeah, Desmos. Okay. Does anyone remember the function? No, the actual function. X minus 2? Okay, I need to mess with this window. I want to shrink it down. So I'm going to make these y values be like 500. Oh, there we go. Let's change the colors a little bit. Okay, what was the equation for that parabola? X squared. What else? Plus 2x minus 4 plus 4. Hey, look at that. It's a parabolic asymptote. Isn't that cool? It's approaching that forever and ever to the right and left. All right. What's the vertical asymptote? X equals. Hey, look at that. We're approaching the vertical asymptote. Life makes sense. Why is it on the left going to negative infinity, on the right going to positive infinity? Why are they opposite? The factor on the denominator is odd. Odd. So that's why they go opposite directions on either side of x equals 2. That is one beautiful graph. Let me screenshot this. You don't screenshot your favorite graphs? It's for your benefit. I'm going to paste it here. There you go. For your enjoyment, there it is. Now life makes sense. Determine where a graph crosses a horizontal asymptote. We can cross the horizontal asymptotes, not the vertical. Anyone know how we can do that? Find out where the graph crosses that point? Yes, where the y value is 4. You say, what is the equation of this line? First of all, how do you find the horizontal asymptote? We say, just look at the leading terms here. 8x squared over 2x squared. 8 over 2 is, did I get that one right this time? Okay. 4. Y equals 4 is this line here. So how do I tell when the graph crosses that line? That's when the y value is 4. So I set my function 8x squared plus 9x minus 5 all over 2x squared plus 1. I set it equal to 4. And we solve this equation. This is a rational equation, so you are all masters at solving these, right? Maybe. That was on our test. Did I not put one on? I did put one on the test. It had lots of variables though. It was the literal equation. Remember the 1 minus r was on denominator? Okay, what's the first step in solving these? After that, you need to get rid of fractions. How do I get rid of fractions? Multiply top and bottom by 2x squared plus 1. Okay, and hey, look at that. These cancel. No more fractions. 8x squared plus 9x minus 5 is equal to, let's distribute the 4 plus 4. Let's subtract 8x squared. That's nice. Let's add 5. 9x is equal to 9, so x equals 1. We got the order pair 1, 4. And now we know that the graph crosses at 1, 4, the horizontal asymptote. Any questions about that? So the graph crossed, but it has to eventually come back to the horizontal asymptote. So you saw it go above, and it has to come back down toward it and get closer and closer forever, but never quite getting there. Example 4. What gives it away that this is a slant asymptote? 3 is 1 larger than 2. So we'd say n equals 3, m equals 2, and so n equals m plus 1 is a slant. I put SA, slant asymptote. Okay, how do I find the equation of that? We do long division, like the last one. We divide by x squared plus x plus 3. How are we feeling about long division these days? So maybe on the test, I'll just not ask you a long division question, but ask you to find a slant asymptote. 2 birds, 1 stone. Okay, how do we do this? How many times does x squared go in 2x cubed? Well, this simplifies to make 2x. We'll write it above the x term. Then we answer, what is 2x times the divisor? X squared plus x plus 3. 2x cubed plus 2x squared plus, is it? Okay. And we subtract. Are you guys okay with it left as subtraction, or do you want to distribute the minus sign? Okay, let's distribute. The x cubed terms cancel. 5x squared minus 2x squared, 3x squared, 0 minus 6, negative 6x, bring down the 1, and we repeat. How many times does x squared go into 3x squared? Yes, plus 3. And we multiply. What's 3 times the divisor? 3x squared plus 3x plus 9. And we subtract. But yeah, let's distribute the minus sign, minus. The 3x squareds cancel. Negative 6x minus 3x is negative 9x. 1 minus 9 is minus 8. Okay, so the original function is equal to 2x plus 3 plus negative 9x minus 8 is a remainder over x squared plus x plus 3. So as x goes to infinity, this remainder term, this goes to 0 for x approaching positive or negative infinity. That means the equation of the slant asymptote is y equals 2x plus 3. Any questions about this? Yes. Sorry, why is this term going to 0? Because the degree of the denominator is larger. So when I square a trillion, it's going to be a trillion times larger than negative 9 times x, basically. Yeah. So when the degree of the denominator is larger, for large values of x, it's going to go to 0. So our equation will approach this slant asymptote. Okay, what type of asymptote would this have? If the numerator has a degree 2 larger than the denominator, it would look like an x squared term, so a parabola, a parabolic asymptote. And you do long division like we did in the other problem. So I'm going to skip this for the sake of time. I would say refer to the first one we did here. That was so beautiful, I had to take a screenshot. Oh, there it goes. Okay. Why is my pen not working? Okay, it's working again. So this one, part C, Remember, if the numerator has degree twice the degree of the denominator, it's a parabolic asymptote.